Awesome. So, yes, I am Jean-Marc Maree. I'm a master's student from the Department of Mechanical and Mechatronic Engineering at Stellenbosch University. And I have the fortunate opportunity of presenting two papers today. The first being the opportunities for digital twins for the provisioning, management, and monitoring of heterogeneous IoT devices. Okay, so a bit of an overview of this presentation. I will briefly outline the objectives of this presentation and then discuss the background to present the contextual awareness of the challenge in managing IoT devices. Thereafter, I'll discuss the motivation for this research as well as a value proposition, and then give an illustrative example to present how this would actually be applied in a practical use case. Thereafter, I'll conclude the presentation with a discussion on future work. So, my research objective is to use digital twins to provision, manage, and monitor heterogeneous IoT devices that improves the visibility of an individual IoT device's health and status using the available contextual data of a unique IoT device. The digital twin must use the contextual awareness to introduce autonomy in the self-management of the IoT device. And the digital twin must also support the scalability of introducing new and heterogeneous IoT devices by loosely coupling itself from available services. So the context that we are working in is in a device as a service context. So that may be a very unfamiliar term, but it is an industry term where companies and enterprises can outsource the maintenance of IT infrastructure to domain experts. And in doing so, companies can dynamically scale their acquired devices according to their demand. Also, this can also reduce or sometimes remove the need for an internal IT team for an organization. And this business model has made its way slowly over into IoT, because you could imagine all of your applications would heavily be enabled by digital twins, but it's unnecessary for you to become an expert and have to deal with the overhead for managing all these IoT devices just to get your particular use case up and running. So for a device as a service platform to support IoT devices, it must support the life cycle of an IoT device, which can be summarized into 4 phases. The first being develop, then onboard, provision, and then manage. Within the development phase, this is where new IoT device technologies are integrated within a platform. And then once integrated, the device can be onboarded, which entails the setup of a virtual profile representing the IoT device and authorizing the IoT device's digital virtual profile on different networks and services. And this process can also include the process of transferring files and operating systems onto the device to ensure essentially that this device can interact with a provisioning server to undergo a provisioning process. And this provisioning process typically starts with a device making a request to a provisioning server, and then the provisioning server will authenticate the device, authorize it, generate unique credentials, and transfer those over to the device. And this process, the aim of it is to ensure that the device is able to enter an operational phase where it can be managed and monitored. In our context, the management is installing applications onto the device and then monitoring the health and status of the device. So to do that with an IoT device, with a single type of IoT device, it's pretty simple. But there are there's a lack in standardization of different types of IoT devices. And this is because IoT devices are dependent on the use case. So there's different functions that IoT devices must perform. They use different communication technologies and are used to measure different types of data. And as the heterogeneity of your managed and monitored IoT devices increases, it becomes very, very complex to monitor and manage the devices and integrate them into a type of platform. Also, as the heterogeneity increases, you have to adhere to an organization's security requirements, which also becomes very complex. But the aim of our research is to not develop another standard, but to develop a system where we can embrace the differences and the heterogeneity of the IoT devices. So that is what led to the use of digital twins that represent the IoT device. So digital twins, we all know they represent a high fidelity model of the device throughout its various lifecycle phases. And there's a bidirectional automatic exchange of data between the physical and the digital twin. And the digital twin contains data, models, and services to use this contextual data to make these automated decisions. So the state of the art of IoT devices or management platforms at its current moment. So we can manage the apps installed on an IoT device. We can use spyware to integrate with heterogeneous types of IoT devices. And we can, there has been hinted at the use of digital twins representing IoT devices. And then cloud services do support the lifecycle management of IoT devices that support their software development toolkit. The state of the art, however, approaches the service-oriented architecture approach to software development, meaning that the services are well-defined, modular, loosely coupled, and independent from one another. And these services, often it's challenging to exchange data between them because of rights and roles. So the gap in the current research is the support for the different life cycles of heterogeneous IoT devices, and then also being able to have all of that contextual data to infer status of the IoT device, and then of the loose coupling of the device's representation from its available services. And then lastly, the use of digital twins to manage the IoT device through various lifecycle phases. So why am I doing this? What is the motivation for this, for our particular context in device as a service? So the digital twin of the IoT device will represent the IoT device's capabilities. And if, for example, a stakeholder's application must be installed on the device, the digital twin of that device can then infer the compatibility of the application with the device and decide whether it is suitable to install or not. Also, the IoT device can be characterized by different types of data sources. So there are those that are reported by the device, such as RAM and CPU usage. And there are those that could be reported by external monitoring systems, such as the network activity and the power consumption. And being able to integrate and centralize all of those data sources presents the opportunity for this contextual awareness of and presents the ability to fully characterize the IoT device and then also make automated decisions using that information as well. And then you can manage groups of devices. So with the digital twin type aggregate as an example, if an application for a particular geographical region is required, then we can apply that application without too much modification. And then lastly, the separation of concerns with the interactions with the device. And then the value proposition of this is that you can refer digital twins for this application is inferring a representation of the device. And then also when making changes to device or introducing new devices into such a system, the propagation of change is then limited. There's also the digital twins autonomy, which then adds additional logic and using contextual data paired with the models being rule-based or machine learning models helps infer the true state of the IoT device. So a very quick example, how would this be done? If we have a use case with a Linux-based IoT device with a connected peripheral, I want to also emphasize this is in the paper if you want a bit more detail. And this Linux-based device is used for object detection for quality assurance, as an example. The challenge that needs to be overcome is that the device must be pre-configured to separate the network interfaces that will be used from the camera and then for an internet connection. The roles that different digital twins would play in such an application is the prototype, or a digital twin prototype would have a pre-compiled image. The digital twin aggregate or type aggregate will provision a digital twin instance. The instance will provision the device and represents the device. And then the aggregate will manage a group of devices. And how that looks in application would be as such, where the aggregate will apply a group configuration to the instance, and also the type aggregate gets a configuration from a prototype, but then the digital twin interacts with the various services to ensure that the device is capable of operating in its production environment. So, conclusion and future work. The conclusion of this is we are using, well, the management of the IoT devices, the heterogeneous IoT devices is very complex, but we're overcoming a lot of these challenges found in the heterogeneity by using digital twins. And in doing this, the digital twin can orchestrate the management of the device's life cycle and autonomously manage the device using the available contextual information, and separates the concerns of the digital twin to its associated IoT device. As mentioned, this presentation is more the opportunities, but the next presentation I'll present an architecture where this can be applied within your particular use case.